and welcome to this tutorial. In today's session, we will explore the process of integrating Swagger into a Spring Boot application to create comprehensive API documentation. Our journey will cover the following key topics. In Introduction to Swagger, we will begin by understanding what Swagger is and why it's such a valuable tool for API documentation and testing. Next one is project setup. We will set up the Spring Boot project from the scratch. We will discuss the essential dependencies for Spring Web, Spring Data JPA and Lombok. Additionally, we will emphasize the importance of using compatible versions of Spring Boot and Swagger. Next topic is proceeding forward. We will immerse ourselves in crafting an API controller, for example, employee controller. Here, we will avoid covering CRUD operations. Instead, we will introduce Swagger annotation like @API and @API operation and explain how they enhance the API documentation. Next one is Swagger configuration. We will explore the need for Swagger configuration class and demonstrate how to create a Docket bean using @bean. We will discuss package scanning and URL path configuration within the Docket. Next one is testing the API. We will execute our Spring Boot application and access the Swagger generated API documentation at http://localhost:8080 swagger-ui/index.html. You will learn how to navigate the Swagger UI interface and interact with the various API endpoints. Next one is endpoint descriptions and models. This section will focus on enhancing your API documentation. We will discuss the importance of providing detailed descriptions for each endpoint, including request response examples. Additionally, we will emphasize the importance of documenting data types such as specifying that a parameter is an integer or a string. Next one is enhancing documentation. We will introduce best practices for enhancing your API documentation. You will learn how to use annotations like @valid and @notnull on our method parameters to ensure data validity before processing. We will also address handling database related exceptions like data integrity violation exception, which may occur during updates and deletes. Implementing proper error handling in our controller to catch this exception and return appropriate HTTP responses to the client will be the part of this section. Next is testing and practical tips. We will run through the practical implementations of the changes made to our API. This section will provide you with insights into how your enhancements will benefit your API development workflow. In our final section, we will summarize the key takeaways from this tutorial. You will have a comprehensive understanding of Swagger integrations in Spring Boot and how it enhances API documentations and testings. Now, without further ado, let's dive into the world of Swagger in Spring Boot. Now, let's delve into the world of Swagger. But first, you might be wondering, what exactly is Swagger? In a nutshell, Swagger is a powerful tool for documenting and visualizing your APIs. It's a game changer for API developers because it not only helps with documenting your APIs but also enhances your ability to visualize them. Swagger simplifies the API documentation and provides an interactive interface for testing and exploring API endpoints. It automates the process of generating documentation, making it easier for developers to understand and test the API. Swagger generates comprehensive API documentation, including example payloads, which can be used for testing without the need to craft requests manually. Why is Swagger important? Swagger is a vital tool in API development that goes beyond mere documentation. It enhances the overall user experience. This importance is twofold. Swagger UI unlocking its power. Next one is efficiency in API development. Swagger UI is a central component within the Swagger ecosystem, playing a pivotal role in API documentation and visualization. This user-friendly interface simplifies the process of comprehending and interacting with the API endpoints. It's especially beneficial for API development and testing, eliminating the need for manual query or JSON payload crafting. Efficiency in API development. Swagger simplifies the API development and testing process by providing pre-built JSON payloads for testing, eliminating the need for manual query creation. It streamlines your development process, enhances efficiency, and prioritizes user-friendliness. By embracing Swagger, you make life as a developer easier, resulting in robust API documentation and streamlined development and and testing. Before we dive into the world of Swagger, let's ensure we have got everything in place. Here is what you will need. I am using the code base from one of my Spring Boot tutorials. If you haven't watched that tutorial yet, you will find the video link in the description. I recommend giving it a watch before proceeding with this Swagger tutorial. Now let's get down to business and set up our project. Here is how you can do it. First, open the Spring Initializer. Select Maven as your project type and then Java as your project language for Spring Boot version 2.7.16. Then set the following details. Group is com.dot, TechSoftDot. Artifact is employee management -swagger. Package name com.TechSoftDot employee management.swagger. Packaging is jar. Java version 17. Now let's bring in the essential dependencies for our project. Spring Web, Spring JPA, MySQL and Lombok. Now you can conveniently download these dependencies and import them into your IntelliJ IDEA. Now if you navigate to the form.xml file in your project, you will see the dependencies we have just added. In general, when testing our application, we typically use tools like Postman. After building and starting our application, we test it by providing a URL along with their JSON payload or a query. However, if you prefer not to write queries, Swagger documentation comes to the rescue. Swagger simplifies the testing process by providing detailed payloads automatically. To achieve this, you need to add Swagger dependencies to your project. Now let's proceed with adding these Swagger dependencies to our project's form.xml file. You can easily include these dependencies by copying and pasting the Swagger dependency information from the Maven repository. Once you have added these dependencies, proceed to build your application using Maven. Execute the command men clean install to initiate the build process. Upon successful completion, you should receive a build success message confirming that everything has proceeded smoothly. As I mentioned earlier, I am using my Spring Boot tutorial code base. You can find the code on my GitHub repository where you have the option to either clone or download it. I will provide a link in the description box. I won't be explaining how to create an employee management API in this video because our main focus is on Swagger documentation. I have already covered the API creation process in my Spring Boot video tutorial. I recommend watching it before proceeding with this tutorial. Okay, now it's time to add Swagger annotations to document your API endpoints. We will use annotations like @API operation, @API responses, @API param and others to provide descriptions, response codes and parameter details for each endpoint. In this code, we have applied @API operation annotations to describe the purpose of each endpoint. These descriptions provide context for the operations. Now, our API documentation will be much more informative and user-friendly. To customize Swagger settings, let's create a configuration class. This class will be annotated with @configuration and include a Docket bean to configure Swagger. The Docket bean plays a central role in defining how your API documentation is generated and presented. Here is how you can set it up. In this configuration class, we have defined a Docket bean that uses Swagger to documentation type.swagger2. We have specified that it should scan for API endpoints located in the package com.TechSoftDot.swagger.controller. Make sure to customize the base package parameter in request handler selectors to match the package where your controllers are located. This ensures that Swagger knows where to find your API endpoints. By creating this configuration class, we have set the stage for generating comprehensive and well-structured API documentation. It's a vital step in making your API easily understandable and user-friendly. Now that we have configured Swagger in our application, let's run it and explore the API documentation. First, go to your Spring Boot application class, Employee Management Swagger application. To enable the web framework settings necessary for Swagger, add the @enable WebMAC annotation at the class level. With this annotation in place, your application is ready to launch. Now, let's run it. You will see that our application start up without any issues. Next, open your web browser and enter the following URL: http://localhost:8080 swagger-ui/index.html. This is where you can access the Swagger API documentation. Upon visiting this URL, you will be presented with your user-friendly interface provided by Swagger UI. Here, you can explore and interact with your API effortlessly. If you are interested in viewing the API payload in JSON format, simply click on the link API-docs. This JSON payload represents the Swagger API specification for your application. It includes comprehensive details about your API endpoints and the structure of your employee model. This Swagger JSON specification serves as the foundation for the Swagger UI, which makes your API documentation interactive and easy to navigate. It allows you and other developers to explore the available API endpoints, understand request and response structures, and even test the API directly from the Swagger UI. Now let's enhance our API documentation with Swagger. We will start by making improvements at various levels of our application. First, we are going to enrich our employee model. To provide a better description for the model, add the @API model description equal to employee detail annotation at the class level. Additionally, for the full name attribute, include the @API model property annotation with the description like this: @API model property within bracket notes equal to the employee's full name. Okay, this step adds clarity to your API by providing detailed information about the employee model. Another important aspect is documenting data types. So vital to specify the data types for parameters and responses, helping API consumers understand what data they should send in their request and what type of data they can expect in the responses. You can use the @API param annotation to document the data type of a parameter like this. @API in the parameter, you have to pass the @API param of value equal to employee details, record equal to true. The @API param annotation clarifies that the employee parameter should be of the type employee, providing valuable information for API consumers. Adding error responses to your Swagger documentation is crucial for providing comprehensive and helpful information to API consumers. You can use the @API responses annotation to document error responses. You have to add @API responses. Within this @API response, code equal to 201, message equal to created, response equal to employee.class. Then @API response, code equal to 400, message equal to bad request. @API response, code equal to 401, message equal to unauthorized. Same like code equal to 403 and 404, message equal to not forbidden, and then 404 equal to not found. We have specified several error responses using @API response. Each annotation includes HTTP status code for the error response, description for the error, response optional, the data model representing the error response. This documentation clarifies what errors might occur and how they are represented, providing more details about each specific error. Now let's enhance the update employee method in the service class. We will add validation using @valid annotation and @notnull to ensure that the received employee object is valid. Additionally, we will handle the data integrity violation exception to catch potential database related exceptions. Before implementing this, ensure that you have the necessary dependencies and configurations set up. Specifically, include the Spring Boot starter validation dependency in your form.xml file. This dependency provides the necessary classes for validation, and then build your code using mvn clean install. Now go to employee service to enhance. We are using the @valid annotation without explicitly using @not_null. The @valid annotation is typically used in combination with validation annotations like @not_null to specify constraints on the fields of the employee class. Here is how you can use @not_null with @valid. In this code, we have added @not_null annotation to the employee parameter. This annotation ensures that the employee object passed to the update employee method is not null. It's a common validation constraint to check for the presence of a non-null value. When you use @valid annotation in the combination with @not_null, it provides the comprehensive validation to make sure that the employee object is both non-null and satisfy any other validation constraints specified in the employee class, such as field level constraints. Keep in mind that if you have other validation annotations, example for specific field constraints like minimum length, maximum length, etc., defined in your employee class, that will also be considered when using @valid annotation. This helps ensure that the object is valid according to the defined constraints. And then in the delete employee method, handle data integrity violation exception as it can occur during the deletion operation. Implement proper error handling in your controller to catch this exception and return an appropriate response to the client. Try catch employee repository delete existing employee, catch data integrity violation exception. It will handle the database related exception, example unique constraint violation. With these improvements, our application becomes more robust with better validation and error handling. It enhances the reliability of our API. Moving on to the controller, we have already used @API operation to provide basic descriptions for our API operations. However, it's essential to encourage our viewers to go beyond the basics. When documenting an API endpoint, we should not only explain what the endpoint does, but also provide specific examples of the data it expects and the data it returns. This practice significantly improves API understanding. For instance, consider an API endpoint that calculates the square of a number. You can provide a detailed description as follows. In controller error handling step, we will implement proper error handling in our controller to gracefully catch exceptions thrown in the service layer and return appropriate HTTP responses to the client. This is essential for providing a seamless experience to users interacting with our API. We can leverage the @exception handler annotation to handle specific exception and return custom error responses. Now let's create a dedicated class controller exception handler for this purpose. With this approach, we ensure that our API provides clear, consistent and meaningful error responses when exceptions occur. It enhances the overall robustness and reliability of our API, making it user-friendly and professional. Here we have demonstrated handling two common exceptions, employee not found exception and database exception. You can extend this to accommodate more exceptions as per your application's needs. Now let's test the changes. Stop the server and start it again. Refresh your browser. And you will see this enhancement reflected in your Swagger documentation. Now let's summarize the list of the key points covered in the tutorial. Introduction to Swagger. Swagger is a tool for documenting and visualizing your API. It helps developers understand and interact with the API endpoints. Then project setup. Use Spring Initializer to create a Maven project. Select Spring Boot 2.7.16. Set group, artifact, package and Java version. Next is add dependencies. Add dependencies for Spring Web, Spring JPA, MySQL and Lombok in your project. Next is integrate Swagger dependencies. Add Swagger dependencies in your pom.xml file to integrate Swagger with Spring Boot. And then API controller. Annotate your API controller method with Swagger annotations. Use @API operation to provide description for API operation. Document input parameters and request bodies using @API param. Use @API responses to document error responses. Next one is Swagger configuration. Create a Swagger configuration class, example Swagger config, to customize Swagger settings. Define the base package for Swagger to scan your controllers. Enable Swagger in the application. Add the @enable WebMEC annotation to your Spring Boot application class to enable Swagger. Next is run the application. Start your Spring Boot application. Access the Swagger API documentation at http://localhost:8080 swagger-ua/index.html. View the JSON API documentation at http://localhost:8080/v2/API/docs and then enhance documentation. Use the @API model to provide the description for your data models. Add @API model property to describe specific model attributes. And then error handling. Implement error handling in your controller using @exception handler. Handle exceptions like employee not found exception and database exception. Customize error responses for professional and user-friendly experience. Testing and recap. Test your changes by stopping and starting the server. Ensure that the API documentation reflects your improvements. Testing and practical tips. The API responses and API response annotations in Swagger play a crucial role in documenting and improving the user experience when interacting with your API. Here is an explanation of how they work and the benefits they offer. The API responses annotation is used to document error responses or various HTTP status codes that can be written by your API endpoints. It allows you to provide a detailed description of different response scenarios and the corresponding HTTP status codes. @API response for each error scenario. Within the API responses annotation, you can use multiple @API response annotations to define different error scenarios. Each API response annotation represents a specific error response, including its HTTP status code, a description of the error, and an optional reference to the data model representing the error response. You can customize the descriptions to provide clear and informative messages to API consumers. This helps users understand what went wrong and how to rectify the issue. The API response annotation can also link to a data model that represents the error response, allowing you to define the structure of the error data. This is optional and depends on the complexity of your error responses. Okay, how they improve user experience. Clarity and transparency. The primary benefit of using API responses and API response annotations is that they make your API documentation more transparent. Users can quickly understand the possible error scenarios they might encounter when using your API. Better error understanding. Customized error descriptions provided by API response annotations help users understand the nature of an error. They know why an error occurred and how to address it. More informed decision making. When API consumers receive an error response, they can refer to the associated API response annotation to make informed decisions on how to proceed. For example, if they encounter a 404 error, they know that a resource was not found. Improved debugging. Developers can use the error descriptions and status codes during development and debugging. This accelerates the process of identifying and fixing issues. Streamlined error handling. The standardized approach to error responses simplifies client-side error handling. Clients can programmatically process different error scenarios without relying on ad hoc error messages. API testing and integration. When integrated with tools like Swagger UI, these annotations provide an interactive and user-friendly interface for testing your API. Users can send requests and observe responses while having access to clear error descriptions. Compliance with best practices. Using API responses and API response annotations demonstrate a commitment to best practices in API development and documentation. It shows that you have considered potential error scenarios and provided solutions. In summary, API responses and API response annotations make your API documentation more informative and user-friendly. They empower API consumers with knowledge about potential errors, enable more effective debugging, and improve the overall user experience when interacting with your API. Thank you for watching this video. If you found the content helpful, informative or entertaining, please consider supporting our channel by subscribing. Subscribing is an excellent way to stay up to date with our latest video, and it's completely free. By subscribing, you will be part of our growing community. You will receive notifications whenever we publish new content, ensuring you never miss out on the valuable insights, tips and tutorial we share. Your support means the world to us, and it empowers us to continue creating high quality videos for you. So if you haven't subscribed yet, please take a moment to click that red subscribe button right below this video, and don't forget to ring the notification bell so you will be first to know when we release new content. Thank you to our current subscribers for being part of our community. Your engagement, comments and feedback make this channel what it is. If you are new here, we look forward to having you on board. So go ahead, hit that subscribe button and let's embark on this journey of learning, discovery and fun together. Thanks again and see you in the next video.